Hi, it's Carly McAvoy. I'm looking at part 4 of the final exam practice that we're going through to get you ready for your final exam. I'm going to try to get through all 6 of these questions, but if it gets to be too long, I'll probably just do 4 and come back. When you're simplifying a rational expression like 19, all you want to do is factor as much as you can and then see if there's anything you can cancel. So you could factor this denominator using the box method. You can't do anything with the numerator. If you want to, if you might see it though, that negative 4 and negative 4 add up to negative 8 and they multiply to 16. So in that case, I might see that I have x minus 4 down below. And if you didn't see that, again, you could go out and do the box method, put your x squared up here, your 16 here, and your negative 8x there, and you would maybe guess and check until you got to this. And you would see that the 4's have to be negative because we need negative 4x and negative 4x to make negative 8x. Well, now I can cancel one of these, but I can't cancel both. One binomial can only cancel one binomial. I can't cancel both of those in the denominator. And when I cancel like that, I don't cancel to 0 in the numerator, I cancel to 1. Anything divided by itself is 1. When we're canceling, we're just dividing. So this is what my final answer should look like. In the second one, I can see that there's 3 things that I don't need to factor. I'm multiplying and simplifying. It means the same thing, except we're going to have 2 terms that we're looking at rather than 1. And so the only thing that I really need to factor is this term down here. And you can see that for 4, it's 2 times 2 would be 4, but that would add up to 4 and not 5. So I'm interested in 1 times 4 because I want those to add up to 5. And again, I'm not really going through how to factor here. You can go back and watch my videos on that, but I just want to make sure you understand. To multiply, you're going to factor, cancel what you can. Do you see that I'm going to be able to cancel the x plus 4 on the top and the bottom? And also, because I have an x plus 1 on the top and the bottom, I can cancel that. When I cancel everything on the top, just like back here, I still have a 1, and what's left is the x plus 3 down below. For division, the difference is we have to flip that second term. So the first term, the x plus 2 over x minus 5, there's nothing to be factored, and I don't need to worry about flipping it. The second one, this denominator, is going to go up and be the numerator, and the numerator is going to go down and become the denominator. I'm flipping that. What is this? This is a difference of squares. When you have a difference of squares, so it was in the denominator, I'm going to put it up here in the numerator, and the x goes to the first 2 places, the x squared, and the 25 goes to the second 2, which would be 5 times 5. These are both perfect squares. One of those has to be a minus, and one of those has to be a plus. So this is the factored form of this one that was in the denominator, and we flipped it to be in the numerator. Now the denominator is now x squared plus 3x minus 10. This is going to go down here. And again, you can use your box method if you don't see that, or you can guess and check, however you decide to factor. But what happens is I want 2 times 5 is 10, 2 plus 5 could add up to 3, but I have 1 of each sign, so I know I must have a 5 and a 2, and then I say, well, I have more positive, so I want the greater number to be positive, so it must be x plus 5 and x minus 2. So now when I go to cancel, I can see the x plus 5's cancel, I can see the x minus 5's cancel, and these two are very similar, but they don't cancel because they're 2 different numbers. If you found out that x was 5, you would say this is 7 and this is 3. Well, those are just totally different numbers. I can't cancel anything out of that, so I just need to leave that x plus 2 over x minus 2. All right, in the next one we're subtracting, which is a whole different thing. And the first thing I need to do is find the LCD. And to find the LCD, I need to factor this little guy right here. So I'm going to write the numerator here. And I'm going to factor this. And when I factor this, again, I'm not showing you how to factor here, so please go and look that up. But 25 times 5 would be 125, and that would add to 30. So it looks like x and 25, x and 5, and it's all plus, so plus and plus. And then I have 1 over x plus 5. Now, this is a minus. It's really important that I remember that there's a minus sign in between there. Do you see how the common denominator is going to be x plus 25 and x plus 5? Because it's going to have to be both of those parts because we have both parts there. And then we need an x plus 5, but we already have one. We don't put it a second time in there. So this first term is not going to change. It's still going to be x squared plus x. But the second term is missing. It has the x plus 5, but it's missing the x plus 25. So we would have x plus 25 that we would multiply the top and the bottom by. And so when I have a minus out front, I want to think about this one as a minus 1. So that gives me minus x and minus 25. I always want to remember to distribute that through there. And my LCD, I can just write LCD underneath, or I can write it out. But you don't want to forget that you have a denominator under there. But we changed both the numerators. Now we put them together. You can see that I have x squared minus 25 on the top because the plus x and the minus x dropped out. And then that's a difference of squares. And so I'm going to go ahead and factor that further to simplify. So x plus 5 and x minus 5. And I still have x plus 25 over x plus 5. And finally, I can cancel the x plus 5s, and I'm left with x minus 5 over x plus 25. And I can't go any further there. It's tempting because it looks like you could cancel some 5s and some x's, but these are just two completely different numbers. If this was 1, if x was 1, that would be 1 minus 5. That'd be negative 4 over 26. Just two different numbers. I can't just go hacking those out. Okay, we're at almost 7 minutes. So I'm going to stop this, make this part 4, and I will be back with part 5, which will have these two problems that you see at the bottom of the page, and also the inverse variation problem. We'll just talk about variation in the next video. All right, have a fantastic day. I'll see you next time.